First thing we learned today is an algorithm is set of steps to solve a problem. Second thing is it's a finite number of steps. When I say finite, it means the number of steps ultimately you can count. It's not infinite. You can't say you have unlimited number of steps. All the steps you can count. It may be 10. A complex problem may have 200 steps, or maybe 2000 steps, but it is still finite number, right? That you can count. Third thing that you will see is all the steps contribute to the solution. All steps contribute to the solution. I did not in my example of tea, I did not say to add salt. I did not say bring salt. I did not say, take a break and go outside and watch a YouTube video. I did not say that. All the steps I wrote it is very relevant to the solution, right? So it is basically what we call it relevant steps. That's another characteristics of a algorithm. When you write algorithm, when you write a solution, you focus on what you need. You omit details, not details, you omit irrelevant points, right? So that's another characteristics of an algorithm. Now, another interesting part is definiteness. When you follow exactly same step, you will get exactly same output. That is what we mean by that your algorithm should be very definite. You know that if I exactly follow the same recipe, I will get exactly same output. That it cannot be different. So this is at a high level what we call about what we refer as an algorithm. Now, also, and as I said, this is relevant and effective. Now, in any algorithm, as you see now, you have three parts. And when we write our program, we will develop our algorithm. We'll develop the solution in terms of set of steps, and we'll develop our solution by breaking into smaller pieces. We'll identifying each parts, like what's my input. We'll identify what's processing here, and we'll identify what's our output. Every problem we'll take it, we'll go through the same model so that you are not confused. You understand exactly your input, what's the process, exactly your output.